Hey everyone, welcome to my analysis for SRM IST NCR Campus on PV technology via Retscreen Expert. So here you see the home screen of the software. It's overwhelming to see so much options, but let me take you through this. First off, we have Virtual Energy Analyzer feature allows for the rapid and accurate estimation of the energy production and savings potential for any location in the world employing a 5-star benchmark ranking system and without requiring a site visit. Then analysis types. First off, benchmark analysis allows the user to establish reference climate conditions at a facility site for any location on Earth and compare the energy performance of various types of reference facilities with the estimated or measured annual energy consumption of a facility. Then feasibility analysis permits decision makers to conduct a 5-step standard analysis, including energy analysis, cost analysis, emission analysis, financial analysis, and sensitivity risk analysis. Fully integrated into this 5-step analysis are benchmark, product, project, hydrology and climate databases, as well as links to worldwide energy resource maps. Then performance analysis allows a user to monitor, analyze, and report key energy performance data to facility operators, managers and senior decision makers, including a facility's actual energy performance versus predicted performance. Portfolio analysis allows a user to manage energy across a large number of facilities, spanning multiple energy efficiency measures in a single residential property to a portfolio comprising thousands of buildings, factories and power plants in multiple locations. Another point in this software, you point at any feature, you will be able to see a mini description about it. Then in the right we can see it has default quick access facility types which we can click and get started very fast. Then we see here user manual and e-learning buttons, to which we click it redirects us to the YouTube page of Retscreen Expert e-learning, where one can learn everything about the software and see how others analyzed. Now opening my project. So we're directed to Benchmark Analysis Location tab. Here we select Climate Data Location. Here I have chosen the location of our college as I show you the satellite view the college. This is our facility location. Then Retscreen will suggest a climate data location from where we'll take the info. Either it'll be a ground station or from NASA satellites. We save it and we get to this screen. Here all the details from the source is shown, as we can see. You'll also observe when my cursor scrolls through some words a question mark will come. So what happens here is that you can click to know more about the term that you've clicked, which makes the work easier. And a graph is also pre-knitted which can be changed as per our requirement. Now we can see the graph here. The bar graph shows the solar radiation and the line graph shows the air temperature. The line graph is customizable as per our requirement. Now we get to the second part of the benchmark analysis. In the first part we put in information about the facility, namely facility type, project type, then its description. Now we can also show the details of the one who did this analysis and that of the facility. Also we can add additional information about the same, which can be used by a third person to contact if the need is there. Then we see a graph which is made by Retscreen, which automatically shows us the energy production cost, which is calculated from the database for various types of project we selected. Here I selected power plants, so on y-axis. Now we go to the feasibility analysis. First part of it is energy analysis, in which we go for the first part, that is fuels and schedules. Underneath is electricity and fuels. Here, as we have a PV technology project, it should ideally be 0, but it's not. The reason for that is that how much we try, there will be something or some part which uses fuels and can't be ignored. Next up is the technology part of it, under which is power. Here we are observing photovoltaic -600 kW mono-C. For power analysis we have 2 levels. Now the next question is why level distribution. In level 1 what happens is that almost all values are assumed and only some are user defined. Here we see that we enter the power capacity and initial costs, and operations and maintenance costs are assumed in this case. and the power panel is skipped. Note, here the capacity factor is assumed. Now in level 2 the things are more refined. Here we enter that if the solar tracking in PV is there or not, at what slope we intend to tilt the panels and azimuth angle, then the location data is taken from the benchmark analysis. Then we see the photovoltaic portion of it where we mention the panel details that we're gonna use. Then we go for inverter, we mention all the specifications. And that Retscreen calculates us the summary. Now the catch here is that the capacity factor is calculated in accordance with the values we gave, so it is more accurate. Then we see the next part, then summary, where the energy capacity and values are shown. Then we go for the cost analysis. Here also we have various levels. In level 1 the values comes from THR energy analysis we just did. It comprises of the initial costs and the annual costs and savings. Note, here the savings are shown as 0, which says a lot about the project we intended to do. Then we move towards level 2 where we see the cost breakup in detail. So under initial costs, feasibility, development and engineering costs are kept 0 as I want charge. Then we go for the power system, we see how many panels are used and their costs. Then Retscreen calculates the costs for balancing the system. Then we go for annual costs. Before that let's see periodic costs. Here we know that inverters won't last the whole project life, that is 25 years. They have an average lifespan of 13 years, so it will be replaced at year 13, which will be added here. Now we go back to annual costs. Here we have operations and maintenance costs are also calculated via the database by Retscreen. Now we see that the cost for inverter we deducted in periodic cost should have been counted here by the database, so we'll deduct a minimal amount from here. Again the annual savings were 0. Now we'll go for emission analysis. Here we'll do just level 1 analysis. Here we give TAN-T losses for India, which is 20.7%, 4-5 times more than the wanted levels. Using the location data and climate data we see here we are to be reduced 93% of emissions, and we can see how much that is by watching the photo on the right. We can change the comparison parameters. 2. Then we'll go for financial analysis. Now here we see that it has taken all the cost values from before and taken standard inflation discount values and shown us that the return on the project is very less. Which is the case, as the return value for the Uttar Pradesh is very less. You get less money. This is level 1. Then we go for level 2. We put in the actual inflation percent, which is very high due to economic hit by COVID-19 in India, and this actually shows that there's absolute no payback for us, and here we see our ambitious project not suitable to go through. Then we'll go for risk analysis. Here we see the analysis is performed on equity payback. All graphs are empty as there's none, and we see here the risk is for 10%, which is very high. I would like to conclude that this project was very ambitious, planned to make our Kaleja independent of grid energy, but where we failed is that it's not financially viable, otherwise we would have successfully done. Thank you for being a part of this journey.